Hello my dear students, welcome to my channel. This is I am planning to from today I am planning to discuss class 12 physics. Okay. If you have some, if you need some clarity, if you have some doubt about physics, you can comment or ask me. I'll make the videos according to your comment. Okay. Now first chapter of physics is electrostatic. Okay. Electrostatic means we are studying about the electric charge fields at their rest positions. Okay. Electrostatic statics means the study of charge, forces, electric field at rest without moving. Statics means charge at rest. Okay, then what is electric charge? That electric charge is the basic property, intrinsic property of all elementary particles. Intrinsic property of all elementary particles like proton, electron, etc. Because due to which the charge, due to which the term of charge is formed. In the charge body, what is charge in basically if the two bodies there, suppose there's two bodies there, and before doing anything there's two bodies electrically neutral. If you rub two body, take the example, suppose one is glass rod and another one is plastic rod. Okay, if you rub to each other, they develop the certain type of charge there. Okay, they develop the charge. How they develop the charge? Because all the elementary object, some material, everything is made up of atoms, and atoms contain some particles like electron and proton. If we rub two objects, glass rod and plastic rod, the in the glass rod as compared to the plastic rod, the electron bonds loosely, okay, with their nucleus, and when you rub, they get a certain amount of heat energy during rubbing, and that electron from the glass rod is moved towards a plastic rod. That's why when the electron move from one body to another body, the body becomes charged due to the shortage of electron. Okay, and that's glass rod is becomes positive charge due to lose of electron, and that's plastic rod becomes negative charge due to gain now same number of electron from the glass rod. And this due to this phenomena, the two body becomes a charge, and that charge, whatever charge developed in that two object, it's remain there. It will not move. Which part is rubbed, where these two objects rub, that charge remain in that positions only. Okay, it will not move. That's why it is called electrostatic charge. Actually, electric charge is the basic property of some elementary particles. I already said it is the electron and proton. And in this, due to that shortage of electrons, some body have excess electron, that becomes a negative charge. Some object have less number of electron, that becomes positively charged. Actually, that charge comes from within that object, not from the other surrounding. Okay, that's why you say charge is conserved. How? Okay, I am going to explain how charge is conserved. Think there is a two object is there. Before rubbing and before contacting these two objects, think their net charge is zero, because both the objects is electrically neutral. Why? How they are electrically neutral? Because number of proton and number of electron within an object is same. That's why all the object in this universe is electrically neutral on this, unless with doing something else. Okay. That's why suppose think about you took the two objects, before rubbing them, they are electrically neutral. That means their net charge is zero. Okay. And then when you bring to touch it, when you bring to rub these two objects, then from one of the object, electron is bound loosely. That's loosely bound electrons transport to the another body where the electron bound tightly. Now that's when the body lose the electron, that electron of that body becomes positively charged due to loss of one electron. Then another a body which gain the electron during rubbing this becomes negatively charged, the number of electron gain and lose is always same. Then think, okay, the body lose 2 electron, that means is only proton is exerted, then the charge of that body is 2 plus E. Then a body gain the 2 electrons, same number of electron, and their charge is minus 2e. Then again, if you add the charge after rubbing, their net charge is 0. That's why electric charge is conserved. That means charge is neither created nor be destroyed, but it can be transformed from one body to another. Okay, today we will discuss the basic thing about this. Then from next session, I am going to do some derivations, which is very important for your board exams. Okay. Then charge, additive nature of charge. Charge is like a mass. Okay. If you brought some potatoes from one shop, then some potato from one shop, if you need to put that together, then suppose suppose you brought from 2 kg from one shop and 3 kg from other shop, then if you keep together, then its mass is 5 kg. Like say mass is the mass is like a scalar quantity, same electric charge is also a scalar quantity. There is no any direction for electric charge. And then the addition of electric charge also is same like algebraic additions. Take the charge with their proper sign. If the charge is minus 2, another charge is plus 5. If you want to add them, minus 2 plus 5, then their charge is plus 3. That's why charge is additive in nature. So we can add simple algebraic additions, and charge is it is a scalar quantity. And similarly, charge, SI unit of charge is coulomb. Okay. Then quantization of electric charge is there. Quantization of electric charge means charge cannot be transferred continuously from one body to another body. Okay, charge cannot be transferred from one body to another body in continuous form, but it transferred in discrete form. Suppose example, if you rub the two bodies, during rubbing, the electron transfer from one body to another, but the transfer of electron is always transfer either one electron, 2 electron, 3 electron, but it's never transfer 1.5 electron, half of electron, 1/3 of electron. That's why the charge is not transferred continuously, it transfers in discrete form. Either 1 electron, 2 electron, 3 electron from one body to another. That's why quantization of electric charge is the net charge transferred from one body to another is integral multiple of basic unit of charge. Integral multiple means integer. What is integer? Okay, basic unit of charge. That's why and charge is equals to Na plus minus Na. Either it's negative charge or positive charge. I think you got the idea what is quantization of electric charge. Charge cannot be transferred from one body to another in continuous form. Okay, it transfer in discrete form. Either one piece of electron, 2 electron, 3 electron, but it never transfer a fraction of electron. Okay, that means that's why Q is equals to N. N is integer, either it transfer 2 electron, 3 electron, 4 electron, 5 electron. That's why Q is equals to N. This is the formula for quantization of electric charge. Then, there is a gold leaf electroscopes is there. Electroscopes is there, gold leaf electroscope. That is a device. Okay, that is a device which is used to measure whether the unknown body is charged or uncharged. How that bodies function, I'll just explain by making some rough thing. This is a one box, transparent box, and why this box is there? To prevent that gold leaf from dust particles, molecules. Okay, to prevent the gold leaf. And there is a hole is there, which is covered by rubber. Then in between this hole, one conductor is there. Conductor means which can flow the charge if it was there. Then at the end of this conductor there is a gold leaf is there. They take one gold thin leaf, and they'll break at the middle to form like a inverted letter V. Okay. Then there is a metal knob is there. And if there is a unknown body is there, suppose think this is an unknown body, okay, we don't know whether this is charged or not charged, then the function of this gold-linked electroscope is just bring this charge. Suppose this is the charge, then just touch the metal knob. If it is charged, then the charge of these bodies flow through this metal rod to the gold lead. Okay, and when the charge flow through this gold lead, it gets the same nature of charge, either positive charge or negative charge. Then same nature of charge, you already know the same charge repel each other. Okay, opposite charge attack. That's why if these bodies were negatively charged, if we touch this conductor and metal now, the charge start flowing and it reaches the gold leaf. And this both the gold leaf get the same nature of charge. That's why it gets diverse. If diverse most, that means this body's most charge strength is more. If the diverse is less, then charge strength is less. The charge is small, common, charge is more. Okay, the diverse depends on the diversion of this leaf. Okay. And this is the, you can make this device at home also. Okay, I think you got, if a body touch here, it does not show any diversion, means that body is electrically neutral on charge. If after touching this one, if this gold leaf shows some diversion, that means this body is charged. That's why this is a device to check whether the body is on charge or charged. This device is called gold leaf electroscope. Okay. And then this body is fully packed within the cuboid glass box to prevent from dust particles. Okay, dust particles, moistures. Now then everyone knows there is a dual nature of charge. One is electric negative charge, one is positive charge. How to distinguish whether it is positive, electric, how to know how many type of charge is there. There is many explanation is there, but this is not important. Just keep in your mind. We have two type of charge. Okay, two type of charge. One is positively charged and one is negatively charged. A body is positively charged if the body use the electron. Then if body is negatively charged, it gains the electron. Now then after that we have Coulomb's law. Coulomb's law is there. Okay, and Coulomb's law is very simple and easy is there. And Coulomb's law actually is applicable with only point charges, stationary charges. If the charge is moving, then Coulomb's law is failed to explain. It does not say anything about what force is there, or what type of electric field is there. If the charge is moving, it failed to explain. And Coulomb's law is applicable only for 2-point charges. If there is more than 2-point charges, then he also failed to explain. Now, what is Coulomb's law? Coulomb's law is very simple. Okay, Coulomb's law is very simple. Okay, if you have regarding the language, you can comment me. I will change the language. I know the 3 languages, little bit English and some Nepali. I know the Nepali because I am from a Nepali background. Then little bit Hindi. Okay, and if you have some problem regarding the language, you can comment. Force as a direction. Okay. And according to, suppose this their separation is R, then according to Coulomb's law states that the Coulomb's law says that force of interaction due to 2-point charges. Interaction means either it is attractive or repulsive. If the charge is same nature, then it is repulsive. If the charge is opposite nature, then it is attractive. Interaction means 2 kind of forces. Okay, either it is attractive or repulsive. It's directly proportional to product of magnitude of 2 charges. It's very simple. The product of magnitude of 2 charges. And force is inversely proportional to the square of distance between them. Okay, square of distance between them. This is the statement of Coulomb's law. What is the statement of Coulomb's law? The force of attraction or repulsion between 2-point charges is directly proportional to the product of magnitude of 2-point charges and inversely proportional to the square of distance between them. that force acts along the line joining the 2-point charges. And according to this statement, if you combine these two statements, then F is equals to 1 by 4. F is equals to Q1 Q2 by I square. That means the Coulomb's force between 2-point charges is directly proportional to Q1 Q2 and inversely proportional to square distance between them. And to remove this proportionality constant, there is some constant values there. Then F is equals to K Q1 Q2 by I square. What is K? K is the proportionality constant. Proportionality constant, K equals to how much? 1 by 4 by epsilon naught. Then value of 1 by 4 by epsilon naught is 9 multiplied 10 to the power 9 Newton meter square per Coulomb square. Okay, this is the value of K. And epsilon naught means the this is called permittivity of free space, permeability of free space. That means the medium between this is air. There is no any medium, only air is there. Okay. Now then after substituting the value of K here, 1 by 4 pi epsilon naught Q1 Q2 by I square. Now this is called Coulomb's force. Okay. Now I already said Coulomb's force is applicable only for 2-point charges. Then what is point charges? If the distance of observations as compared to the size of charge is large, then that charge is assumed as point charges. Then distance must be always bigger than the size of the charge. Okay. Otherwise, if the distance is less than the size of the charge, size of the atom, then that force is called nuclear force, not Coulomb's force. Now, this is the permittivity of free space. Then actually value of epsilon naught equals to 8.854 into 10 to the power minus 12 Coulomb per Newton per meter square. Okay, Coulomb square. Okay, first Coulomb square, meter per meter square. Now this is my first introduction video, first introduction sessions. If you like these videos, please comment and share with your friend, and comment what subtopics you want to learn. Okay, from next I'll teach how to write the Coulomb's law in vector form. Then after that we will go to the topics. There's dipole. What is dipole? What is dipole moment? Then in this chapter, the two important things is electric field due to dipole, either axial and equatorial. Every year out of these two, one will come every year in board exam. Okay, and okay, this is my first step towards the physics. Okay, if you like this video, please comment me. Your comment gives us some push to do whether I have to continue or not. Thank you for watching. We'll meet in the next video. Bye bye. Take care. Stay at home and stay safe at home.